Section 513, we're going to use factoring to solve some word problems. So the target is to go through the 5-step process to solve a word problem with a polynomial equation. So just to recall what those 5 steps are, read the problem carefully, define a variable, set up an equation, solve the equation, and check the answer. Or in other words, does the answer make sense? So here's the first one. If a number is subtracted from its square, the result is 30. Find the number. So step 1 is to read the problem carefully. Step 2 is to define the variable. So let's choose x as our variable, and let's let x be the number. Okay, so the number is subtracted from its square. So let's go to step 3. Let's write the equation. The number is subtracted from its square. The result is 30. So there's our equation. X squared minus x equals 30. Step 4, solve the equation. So this goes back to what we did yesterday. Let's get everything over to one side. So we'll subtract 30 from both sides. Let's factor x squared minus x minus 30. This is one that's easier to factor. So since the coefficient for x squared is 1, we know the first terms in both of these binomials will be x. I need two numbers that multiply to give me negative 30 and add to give me negative 1. That would be negative 6 and plus 5. Product of zero properties, or the property of zero product says that x minus 6 will equal 0, or x plus 5 will equal 0. Solve both of these equations and I get x equals 6, or x equals negative 5. So although it said find the number, there are actually two possible answers. X equals 6 or x equals negative 5. Find two consecutive negative odd integers whose product is 255. So let's define the variable. Let's let x be the first odd integer. So the next consecutive odd integer after x, and we've done this in the past, will be 2 more than the previous one, so x plus 2. Let's find two consecutive negative odd integers whose product, which means we're going to multiply the two odd integers. And the word is translates to the equal sign 255. So let's solve this equation now. Let's clean up the left side by distributing the x. Let's bring the 255 over by subtracting 255 from both sides. And I get x squared plus 2x minus 255. Now this is a more difficult polynomial to factor because 255 is big, but fortunately the coefficient for x squared is 1, so you know the first terms in the binomials will both be x. So I need two numbers that multiply to give me negative 255, and when I add those same two numbers I get 2. Now what might be helpful is to get a factorization of 255 to find these two numbers. So I'll start with 5 times 51, and 51 is 3 times 7. So you know 255 is 5 times 3 times, sorry, not 7, but 17. 5 times 3 times 17. I need two numbers that multiply to give me negative 255 and add to give me 2. what if I take 5 times 3, which is 15, and 17? I think that would work. So let's put the plus 17 here and the minus 15 there. Now the property of zero product says x plus 17 equals 0, or x minus 15 equals 0. Solve both of these equations and I get x equals negative 17. Here I get x equals 15. But remember, negative odd integers, so we reject 15. So that means negative 17 is the first of the consecutive odd integers, and the next one would be negative 15. Let's try this one with a rectangle. It says the length of a rectangle is 6 more than 3 times its width. The area of the rectangle is 144 square centimeters. Find the dimensions of the rectangle. So let's define the variable. So it explains, or describes, I should say, the length in terms of the width. So I'll let W represent the width of the rectangle. And the length, it says, is 6 more than 3 times its width. 6 more than 3 times its width. The length will be the expression 3W plus 6. So now, the area of a rectangle is the length times its width is 144 square centimeters. So step 3, the equation W times 3W plus 6, that's length times width, is 144. There is your equation. Let's solve. So I need to clean up the left-hand side first. Let me distribute the W, and I get 3W squared plus 6W equals 144. Let me bring the 144 over to the left by subtracting it from both sides. And I'm left with this polynomial equation, 3W squared plus 6W minus 144. You need to factor this. Now remember your factoring flowchart. Top box is GCF, which in this case is 3, which makes this a lot easier to factor. And 3 goes into 144 48 times. So now I need to factor this W squared plus 2W minus 48, which is on the easier end of the spectrum. Remember to bring your 3 down along. Two numbers whose product is equal to negative 48, and the sum is equal to 2. That would be plus 8 and minus 6. Now the property of zero product says one of these 3 factors will equal 0, but you know 3 will never equal 0, so don't worry about setting that one equal to 0. But I'll set the other 2 factors equal to 0. And here I'll get W equals negative 8. Here I get W equals 6. Now since W represents a width of a rectangle, we reject negative 8 because the width cannot be negative. So the width is 6 centimeters. And to find the length, plug in 6 for W in that expression. 3 times W plus 6. And you get 18 plus 6, or 24 centimeters. Originally, a rectangle was twice as long as it was wide. So let's let this be the original rectangle over here. When 4 meters were added to its length and 3 meters subtracted from its width, the resulting rectangle had an area of 600 square meters. Find the dimensions of the new rectangle. So here's the original rectangle over here, and it says the original rectangle was twice as long as it was wide. So step 2, define the variable. Let's let W represent the width of the rectangle, and since it's twice as long as it is wide, the length will be 2W. But now we're going to alter this rectangle. It says 4 meters added to its length. So the new length will be 2w plus 4. And then it says 3 meters will be subtracted from its width. So the width of the new rectangle will be w minus 3. And it says the resulting rectangle, this new rectangle, has an area of 600 square meters. Now remember, area is length times width, so we'll take this new rectangle over here, and the equation will be w minus 3 times 2w plus 4, that's length times width, gentlemen, is 600 square meters. Now let's solve this for w. Let's clean up the left. We got a FOIL. Product of the outside terms, first terms, 2w squared. Outside terms, 8w. Inside terms, minus 6w. Combined to give you plus w. Last terms give me minus 12. Subtract the 600 from both sides, and I get 0 on the right. 2w squared plus 2w minus 612. Oh boy, big numbers. But to factor this, remember the top box of your flowchart says to take out the GCF, which in this case is 2. So we get w squared plus w minus 306. Still a bit daunting, 306, but luckily the w squared has a coefficient of 1 now, so you know the first terms in your binomials will both be w. Now just as we did before, start working with 306 and get the prime factorization, or go as far as you need to so you can figure out these two numbers that multiply to give you negative 306 and add to give you 1. So I'll start with 306 being 6 times 51. 51 is 17 times 3. So 306 is 6 times 17 times 3. But I think I got what I need. Look at 6 times 3. That's 18. So we'll go with 17 and 18 plus 18 minus 17. So property of zero product says one of these three factors will equal 0. But remember, 2 will never equal 0, so I get w plus 18 equals 0, or w minus 17 equals 0. Solve these two equations. Here I'll get w equals negative 18 when you subtract 18 from both sides. Here I get w equals 17. Again, since w represents a width, we'll reject negative 18, and our answer has to be 17. And it says find the dimensions of the new rectangle, so we'll go over here to the new rectangle and plug in 17 for w. The new width is 14 meters, and the new length is 2 times 17 plus 4, which will be 34 plus 4, which is going to equal 38 meters. So the new rectangle is 14 meters by 38 meters. And your homework is this.